Remember that we are working on problem 9, which requires us to calculate the current that is flowing in each resistor. Previously, we calculated the current for the total load. Now we will be reversing the process to calculate the current in each branch, which then allows us to calculate the current in each resistor. Following up from our previous video, our next step will be reversing the process to calculate the current in each branch, which then allows us to calculate the current in each resistor. Because R1 is in series with the previously calculated equivalent resistor, all of the current that flows to the load now flows through both of these resistors. And that equals 776 milliamps. So we have solved for the current flowing through one of these resistors, R1, which is 776 milliamps. In order to find the current through the other resistors, all we have to do is work backwards like this. Remember that the other resistor was made up of two parallel resistors. The total current emanating from the source will split between these two parallel paths, one of which is through the 100 ohm resistor and the other is through the 95.3 ohm resistor. Applying current division, the 100 ohm resistor will see 379 milliamps. The rest of the total current will flow through the 95.3 ohm resistor. Remember that these two parallel resistors were made up of two sets of series resistors that look like this. Because these two resistors are actually made up of two sets of resistors in series with each other, the current that we just calculated will flow through each branch and each pair of resistors, as you see here. So this provides us with three more answers. The current flowing through R2, R3, and R6. In order to find the current flowing through the remaining resistors, R4 and R5, we have to remember that they are in parallel and will look like this. The 397 milliamps will flow through the parallel combination, but split like this in proportions that are determined by the value of the parallel resistors. Applying current division, we can find the current through the 45 ohm resistor, which is 397 times 37 divided by the quantity 45 plus 37, which is equal to 179 milliamps. To find the current flowing through the 37 ohm resistor, we could apply the current division again, or simply just subtract 179 milliamps from the total current flowing through the parallel circuit, which is 397 minus 179 equaling 218 milliamps. This provides us with the current through the last two resistors, R4 and R5. And our work is now done. Before closing, I want to remind you again that the EcoFlow Father's Day sale is still available. Simply go to this web address, which will allow you to browse all of the products that EcoFlow are featuring. This brings us to the close of this section of the problem and its solution. If you want the full range of problems and their solutions, you can find them by going to my stand store at this web address. And finally, my newest course that I just added, Bridging the Gap Between Theory and the Practical. This course was developed specifically to solve the pain point of those newly introduced to the power industry. Whether you're an engineer, technologist, or electrician, this course is designed to give you a preview of what's ahead of those just leaving the halls of book learning and entering into the electrical power industry.